Okay, guys, so I've just put the recording back on. So today what we're going to talk about is how you can store information with Android. So there's multiple ways of doing that. You can use the cloud, and there's multiple cloud service providers. Probably the easiest one to use is Firebase from Google. It probably takes, I think it's 4 or 5 clicks to set up, and you can start putting data into a NoSQL database. You can also just put information into a file. You can construct a file and save that into the file system on your mobile device. You can also do other things like using SQLite, which allows you to persist. It allows you to create basic database tables and relationships using a little embedded database called SQLite, and we'll have a look at all of this today. The easiest I've found is probably Firebase. It's I think it kind of goes with this whole new idea of having low code environments. So there's not much to it. Actually setting it up is probably harder than inserting and retrieving data. SQLite requires a lot more coding to set up. You need to write some Java code to set up your table structure, your DDL, your data definition language, and you also need to set up Java code to insert records and select records and do all of those other DML operations like insert, update, delete, and select. We're also going to have a look at permissions as well. And when we look at permissions, we'll look at the permissions that we define inside of our manifest file, and also the runtime permissions that I kind of introduced a little bit last week. Okay. So Firebase, there's a huge number of things that you can get with Firebase. It's part of Google's cloud offering. There's machine learning options, all sorts of different things, authentication, and if you have a corporate application, or if you have your own free or maybe pay to use application, where there's any kind of volume of traffic going into your data store, then you're going to have to pay for that service. I found it incredibly easy to get up and running, and it works in with that idea of NoSQL, flat type of database structure. So there's no relational tables, or there actually isn't a table construct. So I suppose you lose some of those nice guarantees that you get with a relational database. So you might remember from your database class, you've got things like the ACID properties, where your transactions and different operations, they're all isolated, they're all durable, reliable, etc., etc. And you can also save. So with Firebase, it's what we call an eventually consistent database. So it's not consistent straight away. So it's important to remember that. So I suppose for some use cases that's suitable, but for other situations that may not be that may not be a useful or reliable option. But it's just another one of those tools that you can have in your belt, and it's easy to use. So why not? So that's just a quick rundown of what Firebase is. To actually set it up, it's really very, very easy. I'm tempted to actually not run through a project with you, but I might do that anyway, just because we've been doing that in previous classes. So I'm just going to set up a little project. And is somebody chatting to me? Let's have a look. No.
Yeah, he was just Abdullah was asking if is the ease of use the main reason it's selected over other choices. I think he's talking about Firebase.
Oh, right. Okay. Is that? Uh, I think probably the main reason to use it is that you don't have to set up your own server. You don't have to buy any server equipment. You don't have to administer any database server or anything like that. And so, yeah, I suppose that does key into your idea of ease of use, in that you don't have to set anything up. And I'm just going to get back into the chat. There's multiple chat windows here. Okay. Oh, here we go. Yeah. Okay. All right. So I'll just set up a little project and just show you how easy it is to actually set up. So we'll bring the window over here. So new empty project, and we'll just call this the new Firebase example, because I have multiple versions of this Firebase example now. Okay, so Android Studio is just creating the project. Okay, whoops. Now I'll just make my window smaller before I bring it across. Okay, so we won't write any code yet. What we will do though is go into, I think it's tools. It's interesting. I'll just go back to the lecture notes. Okay, so it's actually tools that we need. It's always finding that top level menu is a little bit tricky. So we go into tools and we go into Firebase. And that brings us up this little Firebase assistant. And you can see here with Firebase that, you know, there's multiple options. So it's a huge solution. And there's, in fact, multiple different types of database or data store option. So we're really only just having a bit of a deep dive into one of them. And the one product that we're looking at today is the real-time database option. So you just click on that and open it up, and that's what we want to do, is save and retrieve data. So let me just repeat that again. We just go into tools and then Firebase. It brings up the assistant. And then we click on save and retrieve data. And what we want to do is to connect to Firebase. That's the first thing that we want to do. And so that will open up the Firebase console, and that's where we can create a new project. So you guys are going to create a new Firebase project, and you can do that, but I'm just going to connect to my existing little mobile programming project, which I've already got set up. So just select that one. And so this is linking your project workspace up with this cloud service provider. So just click on connect. Okay, and that looks like that has been implemented. Okay, so we now have all of the connection set up. The next thing that we need to do is to actually add the dependencies for the real-time database to our actual application. So we just click this button. So all of this is all available in the PowerPoint slides, so you can just click through and have a look at it. Okay, and accept changes. So this is just telling you that it's adding this particular support library, and we're also adding the Firebase database support library as well. So we just say accept the changes, and it does it for us. And so that will just download all of those dependencies and bundle it up with our project. And so if we open up our little Gradle file, you can see that those files, those dependencies, they've been added to our project. So we'll just make that a little smaller. And you can see that those dependencies have been added here, and it's been synced up. Although the dependencies have been downloaded and synced with the project structure. So that's pretty much half the job done now. And you can see here it's got this nice user interface. So it's very developer friendly. The next thing that you need to do is to configure some access rules. And so you need to do that from the browser. And that's just over here. So you just come back to your Firebase database console. So I think the thing that's confusing here is that there are literally hundreds of options, right? So you need to go into the project that you've created, right? And then you need to go into the right tab over here. So develop is what we want. And then you need to go into database. And then you need to go into real-time database. And there is another type of data store. This is probably slightly newer than the real-time database, but a little bit more complicated. But that's something that you can have a look at in your own time. So we just go into configuring our real-time database, because that's what we were looking at before. And so what we want to do now is to configure the actual access rules. So we've got our data here.
So when you first go to the console and you open your app, like on the console, like Firebase example in my case, it gives you this option, create a database. Should it do that, or when we like set up with the Android Studio, it should already have created the database for me?
You want to, the first time you do it, you
Yeah.
want to create the database. But I already have a database because I've done this a couple of times before. So yeah, you definitely want to create a database.
Okay.
So then you'll be in your database tab, for want of a better word, or the database card, I suppose. And you should see your database. Your database will probably be empty, which is okay because you haven't added any data. You can manipulate your database. You can expand. So you've got a tree structure, right, with these key value pairs. And you can have parent records as well, and they'll have some child records. So I was really racking my brains over what kind of hierarchy I could have here. So I really only came up with fruit trees as a possible hierarchy that you could put into your application. But if you have a specific application idea in mind, defining your data structure should be a lot simpler. So for example, I can add in a key here, and I could call it username, and then I could put in a value for that. So if I had a database of well, if I had a key called username, I could then save values under that key, and you can create and view all of these data items, these key value pairs, just using the data tab here. And then inside of your application, you can also view and manipulate those data items. So it's relatively flat, right? But you can also have this this level of hierarchy as well. So you can model relatively complicated business rules, I suppose, relatively complicated use cases, but you can't really have any kind of foreign key linkage or any kind of complicated query. Okay, so that's the data itself. And the next thing that you need to do is to actually set up the access rules. And because we're in like a sandpit environment, what we want to do, the first time you load this up, these values will be false, just so that people can't log into your database and publicly read the values and write the values. But because this is just a very simple example, I've just toggled these properties over to true, but you would never want to do this for a production environment. But just to get started, this is fine. So you need to allow people to read and write these values from their application. And I've also found that you need to toggle the authentication off over here. So this is on by default, right? It just makes your code a little bit more complex. And so, when you're getting started, you really just want to have a go at inserting data into your database. You don't want to worry about the added complication of making sure that it's authenticated. That's something that you guys can look at in your own time. But for now, we'll just turn that off. Of course, if you have a production database, and you've got people's addresses and personal details in your real-time database, you need to make damn sure that it's not going to be publicly accessible, so that these key values of people's personal details aren't readable by other people on the internet very easily. So you would, in that kind of situation, you would need to enable authentication and change the read and write value properties that we've got here. But this is how you alter those. This is probably the hardest thing to set up, or probably the most confusing thing to set up, because it's not immediately obvious that you need to do this. But to access your data publicly without all of the complicated authentication mechanisms, this is what you need to do. Okay. So we'll just come back to our code over here. So that's what we've done here. So if you read the little blurb here, that's what it talks about. It talks about setting up authentication or setting up public access. Right, so the next thing that you want to do is to actually write to your database. And so there's a little bit of code here, and I'm normally not a great advocate of just copying and pasting code. It doesn't quite gel with the way I work, but I think in some situations, copying and pasting code can help you get started. So that's what we're going to do here. So step 4, right, it just has a little example of how you can write values into your database. And so we'll just give that a try. And I keep changing between Macintosh and Windows, and the copy paste buttons are always slightly different. Okay, so we've got some code here to now write to that database. So this here where we've got where we use, so what we're doing is we're getting a reference to our database object, and we can then use that to get a reference to, I suppose, a node or a key inside of our database, and then we can set values on that particular key. So let's try the code and see what happens. So far, we've only had 3 lines of code. The rest of what we've done has been some configuration. So I suppose up front, this has been more system administration heavy than programming heavy.
So the message, the string message, what does that signify? Is it a get reference? Where is the message in our real-time database?
So that's just a key. That'll just be a key in our NoSQL database. So I'll put that data in and we can have a look it's just going to run, but that'll be pushing that hello world message under the key message. Should be coming through in a minute. Normally it's interesting, normally it builds quite fast, but today it's a little bit slow. Okay, build successful. Oh, now it has to run it.
So what could be a different word for my reference? Can it be like a key? Like key?
Yes, yeah, I think so. Yeah, you're kind of getting a key, yes, or a node perhaps, because it's also you can possibly have a hierarchy there as well. So we've just inserted some data now. So we'll have a look at our database over here. And you can see what's happened just here. You've got message, hello world. It's also quite interesting so you can delete some values here. So just delete that data item. So when you delete stuff, it flashes on the screen red for a minute, which is interesting. And if I run my application again, right, I'm just going to run it off screen. And we'll just run that again. And what I wanted to show you was that when you insert the record, you can see it coming up in the console for your database. So I don't know if you saw that, but when we have a new incoming message, sorry, not message, but when we have a new incoming key value pair, that new record will flash up on the screen green. So it's quite intuitive and quite nice to use as a developer. But the only thing is that you do have to pay for it. And I'm not entirely sure of the current pricing model, but I think it might be perhaps based on the number of keys, or the number of gigabytes that you've got stored, or the number of accesses and the number of writes and things like that. So you'd have to be careful. You could end up having like a $30,000 cloud bill because you've structured your data in such a way that it puts 100,000 keys into your database. So you have to be really, really careful, especially once you're a subscriber and it's hooked into your credit card. So be really, really careful with that. So we'll just go back to our little example. So we've got our code here. It's writing into the database. So that's step 4. There's also some code here to read from the database. So reading from the database is a little bit different, perhaps, to what you're normally used to with a query. So because it's a real-time database, what we have here is a callback method on data change with this value event listener that gets called as the database gets updated by different clients. So we have to import you can see here we've got some red highlighting, and that's because we haven't imported our record. So easy way to do this with Android Studio or with IntelliJ is to just click on it and use this suggestion, the little hotkey Alt and Enter, and that will auto import that particular class for us. Or if that's not working, you can just click on Import Class, and if you hover over it, you'll also get the Import Class option as well. You can see here that they've given us a little tag value, and so that's just a little static field, and that's just not included here in the little example that they've given us. So we'll just auto generate that. So we can just hover. So whenever you have one of these red errors, you can just hover on them, and normally there's a suggestion here. You have to be really careful, and you have to know what you're doing. Don't just blindly try different random things, because they probably won't work. But what we want to do here is we want to go to more actions, and we want to create the, what do we want to do? We want to create a constant field. And we'll just create the constant field in our main activity. And what we will do is just populate with the little tag Firebase. And this is just a little tag that we can use to populate our logcats output when we run our program again. So we'll just run that program again. So our emulator is starting up, but there's nothing, with this example, I've tried to keep it as bare bones as possible. So, we still have the boilerplate code, which is just the blank project that Android Studio gives us by default. So nothing's coming up on screen, nothing useful. And so we need to have a look at our logcat. And as usual, there's a few 100,000 messages coming up. Don't let that throw you though. And you can see here what we're doing is we're writing to the logcat with the debug level. So we'll just select debug. And we're also writing to the logcat with that Firebase key, or that Firebase tag. And so we can type in Firebase, and you can see over here that our event handler for when values are added to the database, that has picked up that little value there. So there's also a little error handler as well. And so it's all about when that particular reference, right? It's all about when that particular reference changes. So it'll probably be a bit hard to show you. I'll just kill that. Here we go. What I'm trying to show you here is that if you add a key, or if you change this, so if we change this to hello test, that should be reflected down here in our logcat. But if we change any of the other values, we haven't subscribed to those. So if we change the username to J Smith, for example, it changes that key value pair, right? But the way that we retrieve that value doesn't discriminate for that particular key value pair. It's only interested in the key value pairs under the reference message, right? So it doesn't care about that. So any of those other changes that we make, so if we did something crazy and added like a apple over here to our citrus hierarchy, it's just not it's not our query is not able to retrieve it because we're not subscribed to those particular nodes, those particular keys in our database. So if we are interested in the citrus varieties, for example, that little hierarchy, then we can use our database to get a different reference, and we'll get that. We can get a different database reference. So you can have multiple database references. And what will we call? We'll just call this parent. Okay. And so we've updated the code. We of course need to run our program again to get that little change to be reflected. So we've now subscribed to a different node. So we'll now get all of those different change events. So it's not so much about querying, but about subscribing to a particular, I guess, event topic, and then picking up those events when they happen, those on data change events. Okay, so if we go back here, and let's say we add another one here, we'll just add a little test value. And so that should be now coming up or reflected over here, except that it's not. Oh, I think I know why. It's because it's not displaying the entire. It's not displaying the entire tree of values. It's only detecting changes on that parent class. So I think that was probably the wrong key to actually pick up. There's a special syntax where you can use. I guess the best way of porting it is jQuery-esque selectors or descenders that are able to descend your tree of nodes. So that there's an extra option with complex queries and Firebase, so that if you have selected a parent node like Citrus here, for example, you can select that, yeah, you want to subscribe to events that affect all of the child key value pairs as well. I'm not sure of the of the exact syntax for that right now, but that's something that you guys can work out. It's a more complex use case for that little system. So probably the one to use is username, so that we're actually at least using a different one to the message one that we were using before. Okay. Okay, then so you can see here that it's now displaying the value for that rather flat key value pair of username and the value J Smith. So if I change that back to J Casey over here, that will change, and the value will pop up over here in Firebase. So it is a real-time database engine, but I guess you can also have, it's kind of like an events handling system as well. So that's very much a deep dive into Firebase. And I've got another example here where I've got some extra little bit of code for adding hierarchical data, and we'll have a quick look at that as well. So I'll make sure that you've got a copy of this on Moodle, and just make I've got an extra widescreen monitor, and when I move stuff, it doesn't quite fit sometimes. Okay. So before we were just getting flat key value pairs, and we don't need the Firebase assistant anymore, so just minimize that. So over here, we've got flat values for Thursday and night. That's what we've already looked at. If you want to create a hierarchy, you can get your node like this, get a reference to it like we did before. But instead of setting a value on that, what you can do is use the child operator, the child method, to define a child node for that hierarchy, and then set a value on that. So when we run that that code, we get this type of little hierarchy here. So that's why I've got lemon and lemon, lime and lime, orange and orange. That's all come from my little fragment of code over here. We can do other things like remove values. So there's a remove value method as well. And again, it just removes a value, deletes that particular key value pair. So it's a very simple, well, I would say it's a deceptively simple API, deceptively simple interface for programming. Simple things are quite simple, but then if you want to do complicated queries where you take into account hierarchy and how you descend down the tree to retrieve all or some or the adjacent nodes in the hierarchy, that becomes trickier. But you know, there's a whole tutorial on how to actually do that. And there's a little tutorial here on retrieving data, and it covers everything that I've just talked about and a whole lot of extra stuff as well. So, you know, doing complex queries. I would querying the data and also doing complex queries. So that's, again, something you guys can look at. So, you know, I guess the least you need to know is how can you put data into your database, get it back, and then if you have a use case for these more complicated queries, then, you know, have a look at the documentation. I think by now, everybody should be, I guess, learning how to learn. How can you teach yourself this? I mean, I could show everybody how to do these things step by step, and that would work as well. But I think, you know, you also have to start to develop your own way of teaching yourself and how exploring the tutorials and things, just so that you can function as a developer as new technologies come out, and you want to pick them up. So, you know, you don't have to do a class, you can just read the tutorial and work it out yourself. So I leave a couple of things for you guys to explore. And I think somebody was about to say something.
Yeah, just wanted to know, can we only store strings in the data real-time database, or we can also store like objects or array?
Right. So you can store this more complicated data as a JSON object. So if you think about a JSON object, you can have structured data, and you can have arrays in your structured data inside of your JSON object as well. So you should be able to cover all of those. I suppose more complex data types.
So we just convert our object into a JSON notation, and then
Yeah,
we set the like my reference dot set value to that JSON object.
yeah, exactly. And let's have a look at the code again. It would be nice. We can just have a quick look at what's available with myref. Okay, so it's interesting. You do have this option to set an object. So it doesn't, the value, it doesn't have to be a value. It looks like you can have a object, a map, where you could probably define properties and things. Yeah, it looks, I'm not sure if it actually passes an object straight away, or if you have to pass it into a JSON yourself. It's not immediately clear from this documentation, but you know, again, that's something that you guys can discover. Read the documentation. It definitely works for your basic string values. I suspect that it would probably convert objects to a JSON automatically using something like JSON or Jackson behind the scenes, probably JSON, because JSON is the Google mapper for mapping an object to a JSON string, but it might be that you have to get your own mapper and it implements the mapping before you set it into your key. But I suspect it might do it automatically, at least automatically for the use cases it talks about when we look at the little bit of Java doc that was just coming up. Whoops. So just download the source here and just have a quick look at the Java doc. This is something else I often do a lot as a developer, is I just control click into a method. And if you download the sources, normally in Android and a whole host of other libraries, all of these methods, they're all decorated with some Java doc, and you can just read what the Java doc is in situ inside of the actual class file. Doesn't look like it wants to load this this time though. The other thing that you can do is get some documentation while you're typing. You can, this is the Java documentation over here, so you can also take a look at that as well. And actually, look, here's the information that we're looking for. So if you have a very simple class, just a plain old Java object with no constructor, well, with a default constructor, and then public getters and setters, then this set value method should be smart enough to read the fields and values of those getters to get all of the properties and fields and values off of your actual object. So if you have a very simple object, this set value method should be able to handle it and turn it into JSON. So that is Firebase. It's quite powerful, and there's a lot of complicated use cases for it, but it has a relatively simple API. The cost associated with it is quite considerable, so I would be careful using it outside of just toy development situations. So be careful of that. So just go back to the slides. So we've talked about Firebase setup. And yeah, you definitely want to create a new Firebase project. That's the part I skipped because I've already done that. And you can just give it a name of your choosing. And this is just some extra information about the Firebase console and setting everything up. That's the dependencies. We've looked at that. And this is again about the, I suppose, the sandpit mode or the test mode. So you have to toggle these field values over to true, disable security, and I really should have just circled it so it's a bit more obvious, but we need to also disable authentication, disable security. So normally you'd never do this in a production environment. And if you have any kind of real customer or real client for a big corporate, this is the type of thing that they're normally highly allergic to. Recently, there's been a lot of data breaches, and it's really just because people are in such a rush to get their application working that they turn these security things off. So, if you have a little test application like this and it evolves into a real system, then you need to remember to turn the security back on. So I can't stress that enough. A little bit more about Firebase. So I've got a couple of little use cases just for all of those different things I covered earlier. Child nodes, we've looked at all of this before. And there's some information about that complex query stuff, which you guys can look at in your own time. Okay, so that was Firebase. Reasonably simple to program for, although I think it kind of wraps up a lot of complicated ideas with that simple interface of get reference, set value. That's really nice and simple, but there's a lot of complicated machinery behind the scenes that brings all of that together. So now we're going to kind of, I suppose, pivot back to something that's a little bit more, I guess, bare bones, and something that we have to spend a bit more time setting up. I can hear some noises. Is somebody about to say something?
I just wanted to add, like, when you were searching for the word for SQLite, I thought like maybe ancient is a good word, but I didn't want to say it.
Oh, okay, yeah, ancient is probably a good way of putting it as well, but it is fairly ancient, but it is one way of embedding SQL database into your Android application. So some people, they really like interacting with their data, slicing and dicing and things with a SQL database. And so if you want to do that in an embedded way with your Android application, then you can do that with SQLite. Personally, I wouldn't do this. I would prefer to have a nice RESTful API so that I'm not storing a lot of data on the user's phone. But there are certain use cases where storing stuff on the user's phone is preferential. So you could have a cache of frequently used items, and you could store that in a SQLite database, for example. So there's a lot more setup with SQLite. It's probably not, I wouldn't call it a low code environment. I would actually call it a heavy code environment, which is different perhaps to Firebase. That's more low code. SQLite is more code heavy, but that's okay.
Is there like the ORM or something that helps us write stuff into the database, or do we have to use SQL queries to write?
Well, with SQLite, there is no ORM. It's just it's just a raw picture into SQL. So you can. There is actually kind of like a very light ORM where you can define objects and things like a bundle of query parameters. But it's what I would call like I wouldn't really call it an ORM. For everybody else that's listening in on this conversation, ORM is an idea where you map objects to a relational database. So you can have your say your user object, and you can take that object and you can map it into a record in a user table somewhere in a relational database. And so this is like a very common programming pattern for a lot of corporate applications. And a lot of the time, you find yourself, if you were going to set up this object to database kind of mapping, a lot of the time you'd find yourself writing the same code to, you set up your database connection, you insert the data and things, but an ORM layer, it does that automatically for you. But it's not to say that ORMs are perfect. They can be bad in some situations, and certainly it might be preferential if you have a very high performance report or something. It might be better to just write it in raw SQL. A problem with writing raw SQL though is that then you can leave your application sometimes, especially when you're constructing the SQL in code. You can leave your application open to SQL injections, but there's ways around that. But all of this is extra complexity that I didn't, that we don't really need to get into today. I just kind of got sidetracked. So with SQLite, you do all of your create table statements you have a wrapper around that in Java, and you write some SQL to create the table, and you do the same thing with actually inserting data as well. So let's have a look. So this is a pre-cooked example that I was looking at just last night. So we'll just minimize a few of these other windows and open up the file that I'm interested in. Okay, so this is what we want. So to be able to actually set this up, what we need to do is to set up a little SQLite open helper, and it has two very important methods. It has an onCreate method and also an onUpgrade method. And the key thing with this is that it gives you a little database object that you can use, and then you can use that to execute some SQL for actually creating a table and creating the structure and the fields of that table. So you can see here that I've got a little DDL statement to create a table using some of these constant values that I've got in my class. The constructor up here, that is used to actually define the file name for the database and the version of the database as well. And over here, we've got the onUpgrade method, which you can use to perform data migration. So here, you know, I'm just dropping my table, which is not normally something that you'd want to do. You'd probably want to alter your table and perhaps, say for example, if you're adding a column, you'd probably want to do something like alter the table and add a column, and then perhaps add some default values in there rather than just drop and recreate everything. But this is just a toy example, just to show you how this can work. So that is how you can set up a database. Yeah, and I think we've covered those here. That's what we've just covered. So you're writing a lot of Java code to set things up. So it's quite different to Firebase, where you only needed 3. I think it's really useful to make the comparison again. So here we've got an entire class that we need to set up. We need to define the file name. We need to define the structure. And it's not a big class, right? But it's still 40 lines. But in comparison with Firebase, it was just 3 lines of code. And this is just the setup of the database itself. So it's really very code heavy, which, you know, may suit your application or may not. It really depends on what you want to do. So we'll just go back to the lecture notes.
Can you give us a use case for each?
Well, a use case for each. It's a tricky question. I think a use case, I think the use case for Firebase is probably a lot easier. The best use case for that is you don't want to set up your own database. You don't want to host your own database. You don't want to set up your own cloud-based database or your own hosting. You know, you can have things like a SQL Server database in Azure, and that's quite expensive to set up and run. Or you could have a SQL Server database set up on your own computer, and then you have to set up the internet connections and things into your own server. But, you know, you have to build the hardware. So the main use case for cloud and Firebase is that, you know, you don't want to have your own infrastructure. You just want to set up your application.
Also, if you don't want to do any relational stuff, like maybe you don't want SQL stuff, then you use that one, because Firebase, I think, has no SQL.
Yes, exactly. Yeah, exactly. Yeah. And so the use case for SQLite is if you want to store information on your customer or on your client's device, and the way that you want to interact with that information is through a SQL interface. You might have some information like a survey, for example, an application that I helped to maintain last year. While I was working for DXC, it was a little survey application that ran on mobile phones for surveying people on their cravings for different things, like ranging from food cravings to cigarettes. to understand how people manage their addictions and things like that. And that was actually writing all of the survey results back to a tiny embedded SQLite embedded database that was saved on the phone. And then periodically that database would be uploaded and merged into a bigger database remotely from time to time. And I think the main use case there was that the application had to work offline. They the users that were using the device, they didn't have internet access all the time. They didn't want to provide their survey participants with a SIM card, so the application had to work in that offline mode. So that's probably the killer application, perhaps, for SQLite is, being able to interact with data through SQL offline. The big weakness for Firebase is that you have to have internet connectivity. You have to be online, and if that doesn't exist, then your database is going to be cactus. So you can see that this is really the reason why I've wanted to look at these two technologies, because there's some very interesting trade-offs, and they seem to be from one extreme to the other. You've got an online technology like Firebase, and then you've got another one like SQLite, which is entirely offline. So hopefully that answers your question. So we've looked at declaring the constants. We've looked at creating our DDL statements, data definition language statements. So this really just extends your knowledge from your databases class, which everybody probably remembers, hopefully. And then you can get a reference, right? You can get a reference to your database helper to get this writable database handler, and then you can use that to construct SQL statements in Java, which is not something I really like, but it's something that goes part and parcel with SQLite. And then so you create your SQL, and then you execute it, and that gets saved into your SQLite database. The big weakness of this kind of construction, of course, is that if you're pulling these values out of a form or something, then SQL injection, even if it is somebody, I suppose, exploiting a database on their own device, that could be a possibility. So you'd have to have some way of mitigating that. So you can insert values. You can also wrap them up using a content value. So somebody earlier was talking about ORM, object relational mapping. This is kind of vaguely reminiscent of ORM in a very light way. It's not really based on an object definition, but it's based on this more generic content values, I guess, property map, where you can put all of these different key value pairs into your content values object and then write that into the database using the database handlers insert method. So, that might be a nice alternative to constructing a SQL string, which is, not these days not the best practice. Yeah, so SQLite, it's not Oracle, it's not SQL Server, it doesn't have the same performance, it doesn't have a lot of the features that those fully fledged databases have. So it's very much, how can you store data offline in a SQL database fashion? So it's relatively limited, but for that offline application, it's really probably one of the only things that you've got. So just have a look at the SQLite application. I'll just run that. So I won't go through and construct this line by line because it's quite an extensive application. Okay, so just, all right, Gradle is still running. It looks like it's installing, which is great. Okay, so here we go. So I've just got a very simple application here where I construct an insert string when I push this button, and it just keeps on getting added over and over again to my little text view over here. And then I've got a little delete method over here as well, which is constructing a SQL delete statement, and then we're executing that against the database and getting and retrieving that information, and deleting that information. So to quickly have a look at that, we'll just come over here. So we've got our main activity. So you can see here we've got our add button, and it is possible to build those SQL statements manually, but if you ever need to do that, you should always think, if I build this manually and I pull in those values from a form, I've got a possible SQL injection. So try not to do that. If you can use the content values bundle, it's much, much better because that can't really happen. You've got a query method here to query values from your database, and then we've got a little database cursor over here, which allows us to dig those values out and put them into our user interface over here, which is going into this database results view here. So I just kind of concatenate all of those values together and then append them in my results view text field, or not text field, text view. And you can see here that I'm just using the database cursor to get all of those individual columns. They're all based on an index. So it's much lower level programming compared to Firebase. So Firebase was 3 lines of code, but this already to just add a record to our database, we're looking at, I think it's 36 lines. So it's much lower level. But there's advantages and disadvantages to everything. So with this, we've got much more control over exactly what we're doing. Whereas with Firebase, a lot of what's going on is hidden from us. Sometimes that's good, sometimes that's bad. So we've got a delete operation over here as well. And again, just using that database handler. And this time we've got a where clause over here. So this should look kind of familiar, I suppose. We're just getting the last value that gets inserted into our client table, and then using that to lock onto that particular value, and then use that to delete from that particular table. From there, we're just running our query again, and then again, just adding all of that back out to our database results. So this code here actually should probably be modularized and put into a separate method. But for I guess explanation cases like this. I've just left it like it is. Right. So the next thing that I wanted to talk about was permissions and how we can handle that. So that's something that is important for your assignment, your second assignment. And the best way to explain that is to have a look at an example. So just make this a little smaller. It's a little bit better. So with this code, so the permissions example is also wrapped up into the SQLite example. And it's all related to saving a file. So you might want to, and saving a file is again another way of being able to save information to a user's device. So this is again something that you can do in an offline mode. And again, this is even more lower level than using SQLite. So we've gone from a very, very high level with Firebase, then we've come to SQLite, and now we're just using a file directly. So we've gone from high level to very, very low level. So with a file, we need to be able to have the, so you can see there, we've got a little toast message. I don't know if I've talked to you guys about toast messages, but they're a nice little way of popping up a message on screen. So what I've got here is a little event handler to handle the case where I don't have the permission to save my file. So one thing that happens from time to time with student projects is they forget about handling permissions. They're kind of so excited to finish the project or get it done, they forget about what happens in the else block. And oh, this possibly happens with code out there in the wild as well. But what happens is if you don't handle the permissions properly, sometimes people write code such that, you know, if you do something and you're not allowed to do it, the program just crashes. So you have to think about the user experience. So not being able to save the file or do the operation is not a great user experience. So there has to be some way of having some kind of graceful failure. And that's something that you have to build into your application. So here I'm just letting the user know that they can't do that. And so the way that we can overcome this is we can either reinstall the package and it will prompt us to re-enable that permission, which we can do. We'll have a look at, so that's probably the easiest thing we can do. So we'll just uninstall. So yes, we want to uninstall the SQLite example. So we're just building our project again. Okay, so our project's running. So we have a permission that we've set up to be able to use the file. So when I click this button, I'm going to be prompted about that. So you can see here, we've got this prompt, allow SQLite example code to access photos, media, and files on your device. And so the user can say deny or allow. So what we'll do first is we'll say allow. And so you can see we've got a little toast here saying file saved. And so that actually saves the file on our device. And one of the things that you might like to do is to actually have a look at that. And so the way that you can do that is to go into a view and then tool windows. And what you want is, I think it's here somewhere. Yeah, this is what we want. We want the device file explorer. Right, and we'll have a look at our code as well. So we've got an event handler for our file button. We've got this very simple on-click event. We've got the permissions handler, which we'll come back to in a minute. That's all of this block of code here, where we check the permissions. And over here, we've got our save file method, and that's over here. And so I don't know if you guys have done Java programming in the past, but this is just your classic way of writing to a file in Java. And what we're doing here is we're saving to the external storage directory. And so what that does is it maps to the devices or the emulator's SD card directory. And you can see over here that we do in fact have a little test.txt file that we've written to just now. And so we can open that up. And you can explore all of the other files on the file system as well that your application creates. So you can open that file up. To be able to use this View tool, Windows, and Device File Explorer, you have to be connected to an emulator. You can select your device here. You can't do this on an actual device unless you've somehow rooted your device. And we can see over here that we've got our we've got all of our different data directories. And this is what I wanted to show you. So for SQLite, that's also saved on the device's hard disk or on its internal storage. So that's inside of the data directory. And it's got another data directory, confusingly. And then you've got a little data directory for all of the different packages that you've got installed. So if you've got a file, you can either get it out of your file system browser in your device, or you can use the Device File Explorer. And we can come over here, and this is what we want. kc.com SQLite. Yep, go ahead.
So we don't need any permission to store data in this directory, the jkc.com.SQLite. We don't need any permission to store here, right?
We do actually. Okay. So I've already got the permission via a manifest entry. So I just wanted to show you guys where those files for the database end up. So you can see that here. We've got a little 4 kilobyte database for my SQLite database. The first part of the setup for allowing a permission is to add the actual permission to your manifest file over here. And you can see here that we've got this little permission, android.permission.write external storage. And so that allows us to write files into our internal storage and also SD cards and other things with our devices, with our mobile phone or tablet. So that's the first thing that you need to be able to write those files and databases. So you need that permission. So that's, I suppose that's the permission that's advertised on the Play Store. It's an install time permission. And then later on, you, with the runtime permissions, you need to wrap your code in these little checks. So you've got these little checks for checking what happens, for checking that the user has, for checking the permissions database, for want of a better word. There's a little database of permissions on your device for, I think it's probably not so much a database, but like a settings available for each application on your device. And you can check that you've got the permission. And if the permission has been granted, then you can just do the operation. So the first branch of this little permissions check is actually pretty straightforward. You can see here that the method check self permission, it's relatively straightforward. It just uses the application context. The application context in this example, it just comes from our main activity. And the reason that it looks like that is because we're actually, why it looks like main activity.this. And the reason for that is because we're inside of this little on-click listener, which is its own, in the world of Android and Java, that's actually its own little anonymous class. So we have to prefix this with main activity, so we get the right this object. So we get the main activity, the current main activity, instead of the on-click listener object. So that's that part. And then we just simply specify the permission that we're interested in. And if we have the permission, then it's really simple. That this if block here, that resolves to true, right? And then we can save our file. Okay, so then things get a little bit more complicated. I'm just gonna get rid of my device file explorer so I can have a bit more space. And we'll get rid of the package structure as well. And so the else block is a little bit more complicated. There's two branches here. So the first is, should we actually show the permission rationale? So that's another setting that is saved against your application. So if the user has already specified that, yes, they've granted this permission, or if the user has already specified that they don't grant this permission, then the application remembers, right? It remembers that the right external storage permission has already been granted. So it doesn't prompt and annoy the user every time that they go to run the application that the permission's not available. So we can have a quick look to see how that works. So, the first time we did this, we were prompted to enable the permission, but subsequent times the system has remembered in a settings configuration associated with the device and the actual application what selection we actually made. So that's useful. It just makes the application a little bit more easy to use for the users, I suppose. The else block is the interesting part. And so this here is actually the code for actually requesting those particular permissions. So we can, so again, we use the application context over here. It just seems to be a standard thing that's required with these permission requests. I suppose it needs to know which application it's dealing with, so it needs the context. And then you just simply define the particular permission or permissions. So you can see here that we've got this little string array that we've kind of subtly included here in our parameters. So this is actually defining an array of strings, a ragged array of strings. That's why we've got new string, square brackets, and then these squiggly brackets. In our case, there's only one permission that we're interested in prompting for. And then we've got a little constant called write external storage, and that's actually the result code that we get back from the permission check. So if we get that back, then it means that when we've handled our permissions check, we're going to get that value returned. So, you know, when your application's running, there could be multiple of these permission checks happening all at the same time, possibly. You might have different applications running. And so that allows you to discriminate and take action based on that particular result code. So this is not the manifest.permission.write external storage constant. This is a constant that we've defined up here, and that's just a little result code. So just navigate back. So that requests those permissions, and then the actual part that is the magic, I suppose, is this little method here, on request permissions results. So it comes back with the request code, so you can know if the requests relate to your application and for which particular permission it was that you were looking to get, because there could be multiple permission requests. And then there's a little bit of code here to work out whether the permission was granted, right? Using the grant results, which come back as an array. And if that's correct, then, you know, we want to save the file. Otherwise, we want to make a little toast message just like this. So we make the toast using these parameters and then show the toast. And that will pop up those little messages that we see when we've been clicking the file button. So you can see file saved. That's just another little toast message. That's this little toast message here. So that's permissions in a nutshell. You can also interact with your permissions through the settings for your application. So if we go back into our launcher, we can long click on our application icon, and then we can go into app info. And so a cheat, I suppose, I probably shouldn't tell you this, but a cheat, if you want to avoid all of this permission stuff, or if you're just having problems with your permissions or they're not working correctly, your application's crashing, a cheat is to just come in here and just enable the permission here for whatever permission it was that it actually wanted. So you might be having problems with your storage permission. It's not working. There's something wrong with your permission request code. It's not requesting properly, or it is requesting, but it's not doing anything with the results. Things aren't working as you like. You want to see if your code works, then you can come in here and enable the permission, and then everything will start working. So this is something that's particularly useful, I suppose, in the early stages, perhaps, of assignment 2, where you may not have all of your location coarse and fine location permissions set up properly. You can come into the application permissions and just enable them through the control panel. So I'm going to disable the storage permission, and we'll have a look at what happens to the application. So we'll just click back in here. And you can see here that now that we're trying to save that file again with the button, with our save file button and event handler, you can see here that it's coming up with can't save file, no permissions. So you can turn those on and off. What happens is that sometimes people only code for the case where the permission's on. So be careful of that and make sure that you code for the case where the permission is also off, so that, you know, if something is not available, you've got a graceful degradation of your application, or some kind of graceful failover for your application as well. So that's permissions. I think I've covered everything there. And I think that's pretty much it. Was there any questions, guys? Okay, we've got one question from the chat. Is it common to not have any non-runtime permissions and ask user manually for the permissions? So the permissions, there's a little bit of a story to that. So with Android, prior to version 23, all of the permissions were in fact install time permissions. So write external storage, that was an install time permission. But I think what's happened is that Google have wanted to lock down those permissions even further. iOS, they have this runtime permissions model as well. So I think they wanted to match that as well, to say that, you know, their devices are just as secure with this runtime permissions model as well. So they've added the runtime permission model as well. So on older devices, you don't have runtime permissions. It's only for newer devices. So if you have a really old phone, you also need to make sure that when you're doing these permission request code, that it's also going to work on an older device, because the runtime permission stuff, it doesn't work on older devices. So that's the story with that.
But if we are targeting devices which are, say, which
Both.
do, yeah, I mean, we are targeting higher end devices, not the old ones. Like if we say after 5 Lollipop, then will it be okay to not put anything in the install time permissions and just have the runtimes ones?
Right. So it's interesting, right? You actually have to have, you still have to have the permission in your manifest file. As if, so this is the original request for a permission for install time permissions, right? You have to have that as well, in addition to the runtime permission handling.
Okay. Okay.
So you have to have both.
So in older devices, this is sufficient, but in the newer devices, you have to have both to write to the external storage.
Exactly. Yeah. Exactly. Yeah. So in very old devices, say if you've got like I don't know, a 4-year-old phone or something, probably older. Like I'm thinking more like Android 2. This was all that you needed. But you know what? Sometimes you have a client that has an embedded application that they use on some older devices. Say there might be a car rental company, and they've got some tablets that they use for checking off the condition on some rental cars, and that's their own corporate embedded application that's only available on their tablet, and it's an Android 2 application. So you know that might be the kind of situation. It's not an application that's available on the Google Play Store. It's just hard coded and embedded onto the tablet. That's the only thing the tablet can do. So you know you get with these kind of weird corporate applications, these older versions of things. So you know if you go into a company that does contracting for a lot of external clients, these are the types of things that you might be asked to program. So don't think that you can escape some of the older and maybe crappier APIs, because it might be that somebody's out of date code is still used in the field in the wild, and they might want a small change to it. But they may not necessarily want to upgrade it to the latest and greatest. So I guess you have to be aware of that. So that's pretty much it from me, guys. Any other questions? I'm going to take a break for 5 minutes. I'll be then back on the line to, well, maybe 5-10 minutes. I'll be then back on the line to see if you've got any questions. And also in 5-10 minutes, I'll also upload the new versions of these projects and also the lecture notes that I've just gone through. I made a couple of minor changes to the lecture notes that are available on Moodle, just some minor updates for this year. So that's it. I'm going to stop the video or the recorder, and
So